Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing an MIT Integral B question. I actually can't remember which question this one is, sorry, just give me one moment. Where is it? This is the 2023 question 5. The integral we'll be taking a look at is the integral from 0 to 4 of x choose 5 dx, okay? So what makes this one particularly a bit strange is probably this thing in the middle. Now this thing here, if you've done combinations and permutations, will be a bit familiar to you. This is basically a different notation for writing something choose something. So pretty much x choose 5 is exactly the same as pretty much this thing that we've got in here. Now in combinations, if we have n choose r, that's going to be equal to n factorial over r factorial over n minus r factorial, okay? Now this is quite fine at the moment, but what we want to do is we want to kind of evaluate this before we even start integrating, okay? So what we're going to do is just go, alright, x choose 5, so what we're going to have is x factorial on the top, then we'll have 5 factorial on the bottom, and then we'd have x minus 5 factorial on the bottom, okay? Now at the moment, this kind of looks a bit scary to evaluate because obviously you can't integrate everything with a factorial involved unless we're looking specifically at the gamma function, but we can actually simplify this very, very quickly, okay? Because we've got to remember what a factorial means. So if you have 5 factorial, what that means is that you start at 5 and you slowly multiply down to 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. So this number here represents your starting position and you multiply slowly downwards. So we can do the exact same thing with x. So x factorial would be x times by x minus 1. So the number after x. So in this situation here we had 5. The number after that would be 4. Now it has to be discrete, so we're just assuming minus 1. So x times by x minus 1 times by x minus 2. And you can keep doing this pretty much if you wanted to. But we only want to do it to a specific value. So we're going to do this till x minus 5, and I'll show you why in a second. So we go x minus 3, and then x minus 4. And then this is the same as x minus 5 factorial continuum, okay? So rather than going forever, we can just write x minus 5 factorial, okay? Now, if we substitute this bit here, what we get is actually something a bit clever. So what we do is just going to copy this, because I can do that. Check that there. Check this there. That is pretty sweet. Check that there. It's going to be equal to this, and then we just write a fraction here. This would be 5 factorial, which we can value as 120 shortly. But you can see straight away, your x minus 5 factorial, it's on the top and the bottom straight away. So what you can do is you can actually just cancel those terms out. So all we're left with is kind of a weird polynomial here. Now we can evaluate 5 factorial, so 5 times 4 times 3 times 2 times 1. So that's going to be 20 times by 3, which is 60. Then times that by 2 gives you 120, and then times by 1 is still 120. So when you have x choose 5, that's the same as 1 over 120 times by this entire algebraic expression here. So it's going to be x times by x minus 1, then x minus 2, x minus 3, and then x minus 4. Okay, so this is probably the hard part about this question here. We haven't even done any calculus yet. Most of it's just been algebra. Okay, so what we want to do is we want to try and simplify this, and then we can probably use a power rule pretty much. Okay, so straight away, just try and combine these two and these two here to get two quadratic expressions. So this will be 1 on 120, x times by this first one, x times x gives you x squared, x times by minus 2 gives you minus 2x, negative 1 times x gives you minus x, negative 1 times negative 2 gives you positive 2, so that's that first bit there, and this is getting multiplied by this bit here, so x times by x gives you x squared, x times by minus 4 gives you minus 4x, negative 3 times x gives you minus 3x, and then negative 3 times minus 4 gives you positive 12, okay? So we can see in the middle we have two like terms, we have minus 2 and minus 2x, and then minus x, so we combine that as minus 3, so x squared minus 3x plus 2, and then we have x squared minus 7x plus 12, okay? And this has still got x out the front, and then you've got that times by 1 over 120 here, okay? So what we can do is we can probably just keep evaluating this. So we'll multiply this entire bracket by this entire bracket here. So what we can do is just ignore this front bit at the moment because we'll just deal with that later. So we'll just chuck it here. And this is going to be this first term, so times by, so x squared times by that expression there, so x squared minus 7x plus 12 minus 3x times by that expression there, x squared minus 7x plus 12, and then 2, so plus 2 times by that expression there, okay? And then you're just going to multiply that term to each of the corresponding other terms in the corresponding bracket. So this will go to here, here, and here. This will go to here, here, and here. This will go to here, here, and here respectively. Now this times by x is in front of all of this, but we'll take a look at that very shortly. So we just got 1 over 120 x. First bit we're going to have, what we're going to have for that first bit, we should have x to the power of 4 minus 7x to the power of 3 plus 12x squared, okay? This bit here will be minus 3x cubed, and this will be negative 3 times by minus 7 is going to be positive 21x squared, and then you're going to have negative 3x times by 12, so it's going to be minus 36x. This bit here is going to be plus 2x squared, minus 14x, and then plus 24, okay? Now what we do here is we see if there's any like terms. So there's no powers of 4, that's the highest term there, but we can see we have a like term here and here. No other cubics, but you can also see you have a like term here and here and here. And then what else do we have? These two, and that would be about it, I think, okay? So what we can go is 1 over 120 x times by, so it's going to be x to the 4 minus 10x cubed, and then 12 plus 21 plus 2. 21 plus 2 is going to be 23, plus 12 is going to be 35 x squared. Then you have that minus 36 minus 14, so that's going to be minus 50x plus 24. And then we can multiply that x out. So we can have 1 over 120, and just raise the powers of each of those terms there. So this would be x to the 5 minus 10x to the 4 plus 35x cubed minus 50x squared plus 24x, okay? Now remember, we haven't even evaluated the integral. We've just simplified the this bit in the middle pretty much, okay? So what we can do is we can just chuck the integral around it. So 0 to 4 dx, and while we're at it, we can actually just chuck that constant out the front because you can factorize it, because remember, an integral is a sum of terms between two bounds, okay? Now this is actually quite easy to do. Even though it looks very long, it's just a power rule now. So we're just adding 1 to the power and dividing by its new power. So this is going to be 1 over 120 times by, so this will be x to the power of 6 on 6 minus 10x to the power of 5 on 5 plus 35x to the 4 on 4 minus 50x to the 3 on 3 plus 24x squared on 2. And we don't need to add a constant of integration because we've got bounds in this example here, okay? Now we can see straight away when we substitute our bounds, obviously the 4 you would substitute in each of these terms here, but we're not going to really evaluate for 0 because since all of them have an x term and none of them are like sine or an Euler term, they're all a polynomial, it's just going to be 0 if we substitute this other bound here. So we're not even going to bother, okay? So what we're going to have is 1 over 120, then we have 4 to the power of 6 over 6 minus 10 6 to the power of 5 on 5. Oh, I made a mistake there, that's meant to be a 4, my bad. 4 plus 35 4 on 4 minus 54 cubed on 3 plus 24 on 4 squared on 2. Now if you were to evaluate this in your calculator, this entire thing would be equal to 0. Okay, now you can check it using arithmetic if you want to, or you can just check into your calculator. So 1 over 120 won't change the answer. So this integral up here is equal to 0. Okay, and that's about it. If you have any questions about this integral here, leave something in the comments and I'll try my best to answer it. But I will see you in the next one. Make sure to like and subscribe.